Our third speaker of today is Dr. Jurgen Kool. Dr. Kool is a senior plant pathologist at Wageningen University and Research, the Netherlands. His work is focused on sustainable solutions, ensuring plant health, like the biological control of fungal plant pathogens using antagonistic fungi, and methods for disease prevention. Understanding disease epidemiology often is the first step into such studies. During the last years, he worked on disease management in cereals, palm fruits, and vegetables, with emphasis on leaf and fruit diseases, and selected in large screening programs new antagonists against apple scab and powdery mildew. He is convener of the International Organization for Biological Control within the working group Biological and Integrated Control of Plant Pathogens. And with this impeccable resume, I would like to welcome Dr. Jurgen. Dr. Jurgen, you have the floor.
In my contribution to the webinar today, I like to discuss the use of biological control products to combat pests, difficulties encountered, and current results. As a plant pathologist, I worked on disease control in different crops, different fruit crops during the last years, in apple, pears, strawberries, etc. And in all these cropping systems, it's common that they increasingly became dependent on chemical crop protection during the last decades. While this happened, they lost part of their natural enemies and antagonists of pests and pathogens because they became victims of the chemical crop protection products. We like to change this now. We like to change the cropping systems. We like to develop resilient fruit cropping systems. This needs a reduction of the use of pesticides. We know that the EU likes to reduce the use by 50% in the next 10 years. And it will only work if our natural enemies and antagonists will come back into our crops, because they play an important role in buffering the cropping systems against pests and diseases. And it will only work if we have biocontrol products available. Such products are originating from the nature, they cause no harm to humans, and they cause minimal or no negative effects on non-target organisms, ecosystems, and the environment. Such commercial biocontrol products are available for a part. We counted more than 350 different species of beneficial insects, mites, and nematodes, which are mass-produced by more than 500 companies worldwide. And such mass-produced beneficials are distributed and released by farmers in their crops. And on the picture on the right, you see one of these beneficial insects laying an egg into an aphid. There are also microorganisms used for biocontrol. We counted more than 200 strains which are registered in the countries mentioned below. They belong to more than 90 species of bacteria, fungi, and viruses. The biocontrol industry is very well organized. There's a major organization that's the International Biocontrol Manufacturers Association, the IBMA. This organization is organizing an annual meeting with more than 1,000 participants for this business meeting. There are also other organizations, the Biopesticide Industry Alliance, the Bioprotection Global Organization. There are major developments in the biocontrol industry. One is there are acquisitions by plant protection industries. In the slide from a presentation from Dunham on the right, you see examples of major companies that's bought smaller biocontrol companies and they merged. There are also major investments by biocontrol companies, especially in production facilities, because with growing markets, you need growth in production. On the picture below, you see one of the bioreactors which are installed recently in one of the companies, a big bioreactor to produce nematodes, to produce fungi and bacteria. There's also an increase in cottage industries, small industries, local industries in certain countries that produce biocontrol for the surrounding farmers. The biocontrol market, it's still small. It's about 4% of the total global pesticide market, but there is a very large increase. So the annual growth rate is 16%. That was the case during all the last years, and it's forecasted that it will continue during the next years. The major biocontrol product groups, microorganisms, the majority, then macroorganisms, and a few products based on pheromones and plant extracts. The biocontrol targets, mainly pests and pathogens. There are only a few products available against nematodes and almost no products available against weeds. When we like to use biocontrol products in open field fruit crops, we face several challenges. There are limitations for the use of biologicals in the open fields. One limitation are the costs for the grower. They are somewhat higher compared to the costs of a chemical control. Why are these costs higher? You can imagine that it's demanding to produce living organisms, to produce them, to store them, and to market them, to distribute them. That is more complicated compared to chemicals. The shelf life of a chemical is many years. The shelf life of a mass-produced insect is a few days. The shelf life of microorganisms maybe months or a year. Another reason for the higher costs is the biocontrol products are much more selective, so they are developed for control of a certain disease or a certain pest or pest group, whereas chemicals are broad spectrum and produced for large markets in many crops globally. Discussing the costs, we also have to consider that there are true costs, so costs for the environment, costs for the society. If we would calculate all these costs together, the true costs, the biocontrol would be cheaper compared to chemicals. That means if you like to stimulate the use of biocontrol, we have to think about the cost structure in the future. Another challenge are the regulations and the registration procedures. For microbial biocontrol products, we need registration, and the procedures are often more complicated compared to the registration of chemicals. There are many risk assessments. These risk assessments are for a part not needed. That's what we as microbiologists are thinking. We also think that many risk assessments are too complicated and can be simplified very much. That would result in a faster procedure, which now lasts many years, several years, and it would be cheaper. So if we like to stimulate biocontrol, we have to change the registration systems. And there are working groups at EU level, at country levels, working on that and coming with new proposals. There are also other challenges. One is for applications in open field crops, the huge surfaces. If you think about fruit crops, huge hectares, huge amount of hectares. If you think broader and include arable crops, the surfaces are really big compared to the traditional market of biocontrol in greenhouses. So production, costs of production, availability of production facilities, this is a real demanding question for the biocontrol industry in the future. There are also other limitations, environmental conditions like low humidity, temperature, rainfall, UV light from the sun. This can be harmful for our biologicals, so we have to face this and to consider this when we develop new biocontrol. They have to be resistant. When we developed biocontrol in the past, we did this as indicated here in this slide. We started with the isolation of candidate antagonists. We tested the efficacy of these candidates in bioassays, on leaves, on potted plants or so, under controlled conditions, and then went to the field. And when we had really interesting candidates, we contacted the industries. And typical for the industries was they asked a lot of questions about our candidates. And these questions, now we collected them, They were very broad, very different kind of questions were asked, like what is the market size? Can we have patents on it? Is there a fungicide compatibility? What are the production costs per hectare? Do you know something about the toxicological risks? Does it work? So also they ask also, does it work? So the efficacy, where we think it's the most important thing as scientists. But for the commercialization, many other questions are relevant. Also shelf life, mode of action, genetic stability, etc., etc. So what we learned from these discussions with industries is that we have to consider many relevant questions, and that we need expertise not only in our own discipline, like I'm a plant pathologist, but we need also expertise in different disciplines in teams when we develop biocontrol. We use a stepwise approach during this development. We consider commercial questions early, we give the cheap answers first, and we avoid expensive field testing with the wrong candidates. I like to explain how we develop biocontrol in using the case apple scab. So we developed the biocontrol agent against apple scab during the last years. Apple scab is one of the most important diseases in apple worldwide. It's causing scab on leaves and, as you all know, on the fruits. It's very common to control this disease with multiple fungicide treatments in the main areas of apple production. 20 treatments or more are quite common. So we used this stepwise approach. In the first step, we asked about the targeted crop, the disease, and the markets. That's very clear in case of apple, worldwide important crop, worldwide important disease. So the market is big enough to justify the development of a biocontrol. Then we thought about the origin of the isolates. We went to unmanaged apple trees, old trees, which were full of biodiversity and isolated a lot of fungi from the leaf. Then we did a high throughput screening on these little encapsulates. We tested for characteristics which can be easily tested and reliably tested in these systems, like growth at low temperature to obtain cold-tolerant strains, sporulation to obtain strains which can easily be mass-produced, etc. This helped to exclude a lot of isolates which did not fulfill these criteria. So the number was reduced. And with the reduced number, we did taxonomy. We identified the isolates. And once the species name is known, you can do database mining. So you can collect all information and literature on these species. And we especially looked for pathogenicity against humans, animals, plants. And all these isolates with such reports were excluded from our material, from our collection. In the next step, we did bioassays. These have to be done on a living plant with apple scab. These were on little trees. They were inoculated with a pathogen, with Venturia inequalis, with antagonists, and after a while of incubation, we counted the development of spores of the pathogen. We found a number of efficient antagonists, a few out of 100 isolates we started with. In parallel, we always tested these efficient antagonists in fermenters, in very small experimental fermenters that mimic the production situation later, so the production in huge fermenters to do the mass production for the product. And we assessed, are our candidates able to produce spores? Can they be produced at low costs? This is an important step, not to guarantee only that the antagonists are efficient, but also that they are suitable for a cost-effective product. And some of our nice antagonists were excluded by this step because it was hard to produce in a cost-effective way sufficient amounts of spores. With mass-produced material, selected material, we went to the field and first in small experiments, then we integrated the use of the antagonist in cropping systems. And the result was that out of several hundred isolates, we found one isolate with the name H39. It belongs to Cladosporium cladosporides. This isolate reduced apple scab under field conditions. We had successful field trials in different European countries. We have a patent in the key apple producing countries on the use of this isolate. An industrial partner developed the product, so the production procedure and the formulation. So a final product is available, and this industrial partner is now busy with the authorization process, so the registration as plant protection product, so that it can be marketed as soon as possible. An example of the use of the biocontrol agent against apple scab. This is a trial from southern Germany. We applied the antagonist and a fungicide in another treatment 10 times during the summer season. In the untreated control, the scab incidence on the leaves was 18%. The fungicide reduced these down to 1%, and the applications of our antagonist, H39, reduced the apple scab incidence on leaves to below 1%. So a very high efficacy under field conditions. The scab incidence on fruits at harvest was high. It was 70% or even more. The fungicide treatment, 10 treatments in the season, reduced apple scab down to 1%, and the biocontrol treatments reduced apple scab on fruits to below 4%. And it has to be mentioned that we used only 30 grams of conidia of the biocontrol agent per hectare. This is a very low amount for biological control agents. This experiment, another experiment, showed that the Cladosporium H39 can efficiently be used in the field to control apple scab epidemics. Example how it looks like. You see untreated apples from untreated control plots full of scab, the fruits. You also see that the canopy is heavily affected, so the trees lose their leaves, and as a consequence, in the following year they will produce not so many apples because they are really stressed. In the H39 treatment, almost no scab on the fruits and a really healthy canopy which is strong enough to produce the next yield in the following year. How to integrate biocontrol of apple scab now in apple scab control strategies. We have two different situations. We have the current cropping situation, the current cropping systems, where we have a lot of fungicide treatments, up to 20, 30 treatments in the season. That's indicated on the top of this slide. In this situation, we can replace some of the treatments by a biocontrol treatment. This has a big advantage, especially if the biocontrol treatment is carried out at the end of the season. This results in less residues on fruits, which is of course very attractive for the grower. This is very attractive for those who are marketing the fruits, and it's a nice market for a biocontrol product. We also like to apply the biologicals in the future resilient cropping systems, and we will need them. If we are very successful with the development of the resilient systems, the systems will be completely in balance because they are naturally occurring antagonists and beneficials, natural enemies. So, in fact, no disease control treatments will be needed as long as the system is in balance. But there may be situations where temporarily the damage thresholds are reached, so there is risk for damage by a disease. In this situation, we have to interfere. We could interfere with a chemical fungicide. This fungicide may partly destroy our resilience, disturb the resilience, and as a consequence, we may have to continue with applications of the fungicides in the season. On the other hand, we can apply a biocontrol product, which will not disturb the resilience, so will not affect the naturally occurring antagonists, etc. So we have one application, and thereafter the naturally occurring antagonists take over again. A short summary. The biocontrol industry is mature. The growing markets have to be mentioned for biologicals. There's an increasing number of products, but we need for the future, especially to support the resilient development of resilient systems, we need more and more specific biocontrol products. They have to be developed in fundamental and applied research. We always do this together in partnerships with industries, so we need strong private-public partnerships. And the aim is to replace chemical pesticides, but the aim is also to facilitate the transition towards resilient cropping systems. With that, I'd like to thank you for the attention. I like to thank the European Commission and the Dutch Ministry of Agriculture for supporting financially our work. And I'd like to thank all my colleagues who helped me to conduct this nice research. Thank you.
Thank you so much, Dr. Kool, for this very interesting presentation. And I'm sure, like other presentations, we will have a lot of questions now to be answered. Alejandra, I give you the floor to moderate the questions.
Thank you. The very first question is, do you see the use of biological control products as the alternative for the sustainable development of global agriculture, given the high prices that you mentioned in your presentation?
I didn't say high prices. I said the prices are somewhat higher compared to the chemicals. And I mean, there are many examples where biologicals are used and where they are used with these prices. No? So it's not that the prices are so high that they are not a economic solution for these crops. And of course, when we develop biocontrol, we know about the prices and how important they are, and we consider. I gave this example. We consider production costs very early in the process to keep these prices low.
Okay, another question from Athanasius Mandis is, how compatible is the biological control agent, Cladosporium H39, with the main commercial plant protection products adopted for apple scab control?
It is compatible with all the insecticides, etc. But of course, it's a fungus, not compatible with all fungicides. No? When you think about is it compatible or not, you can think about applications at the same time. In this case, it's often not 100% compatible with some fungicides. But if you think about alternations in the cropping season, it's the match is perfect and possible. No? Because you have to apply, if there is an epidemic ongoing, you have to apply again and again on the young developing leaves, and you can reach them with a fungicide or you can reach them with a biological. So in alternations, it's perfect.
Thank you. And last question, how should the evaluation and registration system should be adapted to biocontrol products?
That's a big question. I mean, there's initiatives at EU level. There are several working groups. I'm also a member of such a working group thinking about the alternatives. We definitely have to reduce the amount of risk assessments and the complexity of these risk assessments. You know, because these are organisms from nature, and there are mechanisms in nature, for example, restricting the growth of these populations. So they will always go back to low levels after a time, after application. So we don't need all these detailed risk assessments on these questions.
Thank you. Now we go back to the studio.
Thank you.
Thank you, Alejandra, for these moderations. I think we can now go to the last speaker, and I'll leave you the possibility to introduce our last speaker.
And now we continue with our last speaker for today, Mr. Eric Gall, who comes from IFOAM Organics Europe, the European umbrella organization for organic food and farming. Mr. Gall joined IFOAM Organics Europe as a policy manager and deputy director in 2014, after 5 years of working for a member of the European Parliament in the Environment Committee. Beforehand, he worked for 6 years for Greenpeace in France and then in Brussels, where he coordinated the work of European offices in the fight against the release of GMOs in the environment. He also worked for several other NGOs in France and coordinated an EU research project aimed at improving the participation of civil society in research projects and policy. And with this impeccable resume, please let's welcome Mr. Eric Gall. Mr. Gall, you have the floor.
Thank you very much, Alejandra, and thank you for your invitation. I must say I very much enjoyed the previous presentations. I hope you hear me well, and will it be possible to see my presentation, please? Yes, thank you very much. So I will mainly tell you about the state of organic market in Europe in the last years. But next slide, please. I was asked to touch on a few other points first. Next slide, please. So first of all, IFOAM Organics Europe, we represent the whole organic production chain, farmers organization, processors, certifiers, research institute. So we make sure that the organic food and farming sector speaks with one voice towards the European institutions. And we have more than 200 members across Europe. Next, please. Just to make it clear, I wanted to remind you the definition of organic farming. So organic agriculture is a production system that sustains the health of soils, ecosystem, and people. It relies on ecological processes, biodiversity, and cycles adapted to local conditions, rather than the use of inputs with adverse effects. So it's a combination of tradition, innovation, and science to benefit the shared environment and to promote fair relationships and a good quality of life for all involved. It's based on 4 principles: health, ecology, fairness, and care. And actually, organic farming is regulated at the European level. I believe it's the only form of agroecology which is regulated at the EU level. And to touch on the topics of today's, the use of GMOs is banned from organic production. And on the other hand, organic farmers strive to achieve precisely systems which are in balance. So the ideal goal is to always try to reduce the dependence of a farming system on external inputs as well. So I will touch on this in a minute. But first, allow me a couple of minutes on GMOs, because like it was reminded by Dr. Fairbank, indeed, the European Court of Justice has clarified in July 2018 that all the new genetic engineering techniques, such as CRISPR-Cas9, for example, are regulated under the current legal framework that applies to GMOs, meaning that there needs to be an application for an authorization, a risk assessment, and that traceability and labeling should apply as well to these new techniques. And this is a very important point for the organic movement, because the capacity of organic producers to ensure that no GMOs are in their production process very much depends on the traceability system that exists in the EU and in many other parts of the world as well. So I must say that the organic movement has concluded already in 2017 that new gene editing techniques such as CRISPR-Cas9 should not be used in organic farming. And at the moment, the legal framework in the EU is very clear. These are GMOs, genetic engineering techniques, and the legal framework which currently exists should apply. And we wish that it will remain like this, because like it was said, I mean, there's a lot of hype and many promises being made about all the new opportunities that could be open with gene editing techniques, which aim at directly modifying the DNA in plants and animals. But once again, it remains to be seen. There were already very far-reaching promises made 20 years ago, but the GMOs currently in the market, what we see still is mostly crops which are herbicide tolerant, which are put on the market, and a few insecticide and a few plants which produce their own insecticides. So whether this will be a game changer or not, this remains to be seen. But it's really crucial for the organic sector, but not only, for the whole food sector in the EU, which in the vast majority is GMO-free, that these new crops remain regulated as GMOs, and that producers and consumers keep the freedom not to use or not to consume products made from these new genetic engineering techniques. And a last word about that. We need breeding. Plant breeding is very important, but here as well, we believe that we need a systemic approach on plant breeding that does not rely on a, let's say, a reductionist approach or monogenic tolerance as well. And it's one of our objectives as IFOAM Organics Europe to develop organic plant breeding as well. So that was a little aside, and I very much enjoyed, I must say, the balanced messages of the previous speakers, Dr. Feedbank, on the topic. Back to the presentation, please. Thank you. So perfect. So a short word about the approach to plant healthcare in organic farming. As I said, ideally the goal is to have a agro farming system which is in balance, with the aim of reducing external inputs. So the plant healthcare has to mostly rely in organic on preventive measures on the one hand, and so-called indirect measures on the one hand, to reduce the infestation and the pressure of pests and diseases. And it also relies to a certain extent on the use of functional biodiversity, with the ultimate goal of reducing external inputs as much as possible. Next slide, please. So as an example, Dr. Kohl talked about the issue with scab. It seems that in Germany, more than 50% of a new apple plantation in organic farming are scab tolerant varieties now. And as I said before, you know, the approach is not to look for monogene tolerance, but to have a more systemic approach in finding the suitable varieties which are also adapted to local condition. So organic breeding is a very important activity, but it still needs to be developed as well. Next slide, please. This is just an example of the use of functional biodiversity with flower strips. I believe here, this is one of the important tools available to organic producers. Next slide. So to sum up, no GMOs are allowed in organic production systems, neither the GMOs which are currently on the market, neither the upcoming one, let's say, based on gene editing. And the organic movement is also opposed to the use of gene drive. And I believe there are discussions on a moratorium at the level of a conventional biodiversity regarding gene drive. And on the other hand, the use of synthetic pesticides and of, you know, artificially designed molecules is also not allowed in organic farming. So when inputs are needed, organic producers have to rely on natural substances. And here as well, I can very much support many of the messages sent by Dr. Kohl on the importance of biological control and on the further innovation potential of biocontrol solutions as well, which are relevant both for organic farmers on the one hand, but also to conventional producers. And here we also believe that we need to adapt the registration system for natural substances because the whole EU evaluation system is made for synthetic chemicals. which is fine, but it doesn't take into account the specificity of natural substances, and it doesn't take into account the fact that these substances are already present in the environment. There is already a natural exposition background to these substances. So, to make a long story short, we also believe that we need to adapt the registration system so that it's easier to increase the availability of natural substances available to organic farmers. That doesn't mean that natural substances are safe by definition. So there needs to be a risk assessment, of course. And doesn't mean that all of them should be allowed in organic farming, neither. But we think, once again, that there should be specific procedures so as to speed up and increase the availability of alternatives to pesticides for farmers in Europe. And yes, next slide, please. And last word about that, we are also involved in the Horizon 2020 European research project called RELAX, which precisely aims at finding alternatives to some of the substances used in organic farming. I mean, you've all heard of copper, for example. The organic movement has been leading efforts to reduce already the use of coppers, but alternatives are not yet available for all kinds of crops. So we are further leading research work on that as well. Next slide, please. So a few words about the farm to fork. You had a very exhaustive presentation by Dr. Marquardt, so I will only focus on the aspects related to organic farming. So why does the farm to fork strategy include a target to reach 25% organic land in the EU by 2030? In a way, it is a very smart and logical approach because organic farming has proven benefits for farmers. Usually it's more profitable to do organic farming because you have less cost for input and you get higher and more stable prices for your products. But it does benefits for society and for the environment as well, for soil fertility, for water quality, for biodiversity, and so on. Organic farming is regulated at the EU level. It's a well-established and production system. It's very well known by consumers all across the European Union. And I must say it's a very dynamic movement with very solid double-digit growth every year in many European countries. So I will go into details about that in a moment. But let me just say that at the moment, we are at 7.9% of organic land in the European Union, if we exclude the UK. And the projected growth according to business as usual scenarios, taking into account current levels of growth, are that we would reach 16% in 2030. And there are actually already 18 member states that have national targets to increase organic farming. So organic farming can powerfully contribute to EU policy objectives, the objectives of the CAP, but also the farm to fork. The more organic farming you have, the more you have a reduction in pesticides and to fertilizer and in fertilizer to a certain extent as well. Let me just clarify the fact that this target, like Dr. Marquardt said, at the moment, they are not legally binding, they are aspirational, and the 25% target represents a European average. So we do not expect, of course not, all countries to reach a 25% organic farming by 2030. I mean, I think Poland is at 2.4% at the moment. That would be unrealistic. I think the point is that we would expect all countries to have a national target that will represent a fair and realistic contribution to this target. Back to the presentation, please. Next slide. So, like it was said before, the Common Agricultural Policy has a central role to play in reaching the targets of the farm to fork policy strategy, and in particular, as far as organic farming is concerned. So you probably know that the final negotiations on the CAP are happening now, both in the Parliament on the one end and in the European Parliament on the other end. And we're urging members of the Parliament and all governments in Europe to align the CAP to the Green Deal and to the farm to fork strategies. We published a few months ago a report with FIBL on the new eco schemes, which is one of the new mechanisms available in theory in the next common agricultural policy. We believe that it could be a powerful tool to incentivize and help farmers to transition to more sustainable practices, provided that there is a part of a CAP budget which is really earmarked for these eco schemes in the first pillar. And we are asking for at least 30% as a start, that could increase year by year to reach 50% of a CAP budget in the first pillar by the end of the next CAP period. This is very important to ensure a common level of ambition across all member states, and to ensure a level playing field for producers from different countries as well. So we do believe that in particular, the CAP strategic plans that member states will have to design, because member states will have much more flexibility in the types of intervention they will be able to fund under the CAP. We believe, as I said, that there should be a national target in all the CAP strategic plans across Europe, the amount of which will be discussed in discussions with the European Commission and with the organic movement, and appropriate support for conversion to organic farming and maintenance of organic farming as well, as a way to reward organic farmers for the benefits precisely they deliver for the environment and society. Next slide, please. So to reach the 25% target, it's very important that we have measures in the CAP, as I said, but it's very important that we have measures to increase the demand for organic products. And there are tools available for that. If we look at some positive experiences in Europe, Denmark is probably a very good example. They have had a national target to reach 60% of organic products in public canteen, schools, administration, and hospitals. And this has proven a very powerful tool to increase organic demands, but also in return to increase the production of organic products in Denmark. And for example, the city of Copenhagen, in public canteens, they have already managed to reach 90% of organic products in the public canteens. So we need to have this push-pull approach, meaning that we need to have policy support to develop organic production on the one hand, but also policy support to increase the demand for organic products. Back to the presentation, please. So green public procurements can be used to that effect, and also promotion policies. And these are parts of the actions already listed by the European Commission as part of the Farm to Fork strategy. And the Commission has already announced that there will be a budget of 40 million euros for organic farming for the promotion policy in 2021, which is, of course, very much welcome from our perspective. Tax incentives and reduced VAT rate are another options to increase demand. Next slide, please. And all of this should be put together into a coherent set of policy through the Organic Action Plan, because we are expecting a new European action plan for organic farming before the end of the year. Next slide, please. Thank you. And as I said, to make a long story short, we do expect that the action plan will address many of the aspects which are important to further develop organic farming in Europe, to ensure the availability of the inputs needed for organic farming, for example, seeds on the one end, but once again, alternatives, plant protection products as well, based on biocontrol, dedicated research and innovation budget, because most of our research money still goes to, let's say, a conventional approach or approach based on genetic modification. We believe that there should be even higher budget dedicated to agroecology, even though I must say that in the past years, a lot of progress has been made by the European Commission in this respect. Farm advisory services are very important if we want to really, both help farmers to really reduce pesticide use on the one hand, and help other farmers to completely phase out the use of pesticides and transition to organic farming as well. This is a very important aspect. There are, other actions which will be very important and which are already part of a plan at the moment. Next slide, please. So now I will go to the specifics of the state of organic demand in the European Union. Please forgive me in advance. I will pass very quickly to some of the slides, but the organizer will make sure that the presentation is available to you if you want to look at them in more detail at leisure. So next slide, please. First, I must say that this data has been gathered by FIBEL, which is the Research Institute on Organic Farming based in Switzerland. The data is collected and processed in 2019 for 2018, and then it's published early 2020. So this is why this is data for 2018. Next slide, please. So to sum up already, in 2018, 7.7% of agricultural land was organic, and there was an increase by 1 million hectares between 2017 and 2019. I cannot see all my slides here on screen, but there are more than 327,000 organic operators reported in the EU in 2019, and I believe that the market reached 37 billion euros now. Next slide, please. So this is a graph showing the increase of organic land, both in the EU, that's the line below, and in Europe, which includes Norway, Switzerland, and other countries as well. Next slide, please. And this is the increase of organic producers. Next slide. And this is a sum up about the growth from 2017 to 2018. So the land under organic farming management increased by 7.6%. The number of producers increased by 7.2%. And the market also increased by 7.7%. Next slide, please. So the top producers in terms of amount of land are Spain with 2.2 million hectares under organic farming, followed by France, Italy, and Germany. In the EU, the EU average is 7.7%, and in percentage, the leading countries are Austria, which is close to 26% of organic farming, Estonia, Sweden, Italy, and overall you have more than 10 EU countries which already have more than 10% of their agricultural land under organic farming. Next slide, please. So these are once again the countries with the largest organic area in the EU: Spain, France, Italy, and Germany in absolute numbers. Next slide, please. There was an important growth in the production of organic, both in the old Europe, so to speak, and to a lesser extent in the so-called new member states too. Next slide. So the countries where the growth was the highest from 2017 to 2018 was France, Spain, and Germany as well. And in terms of percentage, we have Montenegro, Ireland, Macedonia, Serbia, quite a number of countries. Next slide. So, like in general in agriculture, organic farming land is divided between grassland on the one end and arable crops on the other end, with 11% of organic land for permanent crops. And a large part of it are olives production, grapes as well. Next slide. This is a distribution of organic producers on the one end and organic processors on the other end. The countries with the highest number of processors are Italy, France, and Germany. Next slide. So the European market beyond the EU reached 40.7 billion euros with a very high rate of increase. The biggest market is still Germany, closely followed by France and Italy. And in terms of what it represents on the national market, organic has the highest share in countries like Denmark, Switzerland, and Sweden, with more than 9% of organic of the whole food market, which is organic. Next slide, please. I have a few more data. I think we can pass on this one. Next slide, please. So once again, this is a distribution of retail sales dominated by Germany, France, and Italy in volume. Next slide, please. The same countries have the highest sales value as well. So we can go to the next slide. So the global market for organic food reached almost 100 billion euros in 2018 at the global level as well. And the highest annual per capita consumption was reported in Switzerland and Denmark, around 300 euros. Next slide. You can go to the next again. So a very quick word about imports of organic products. They mainly concern tropical fruits, nuts, and spices, with a huge share for bananas. So with no surprise, most of the imports of organic products into the European Union concerned exotic products, so to speak, tropical fruits, and to a lesser extent, oil cakes for animal feeds, because there's still a shortage of the amount of feed which is available in organic quality in Europe as well. Next slide. So this is my last slide, I believe. So to sum up, developing organic farming can contribute to reaching the EU policy objectives of the CAP, but also the farm to fork and biodiversity strategy. We do have the policy tools available to support further development of organic farming, both at the production level, but also on the demand side, and this is very important. Organic is a global premium market. The growth rate has been very high in many European countries in the last years. We still have a higher growth, more rapid growth in the demand than in the production of organic in Europe, but still we have countries like France, for example. As I said, there was a 15% growth in the production of organic from 2017 to 2018, and as far as I know, this continues at the moment. It's a sector with high consumer trust and credibility. It operates through a full range of channels, from very large to very small businesses as well. It's legally defined and protected by the European organic regulation, and it's a sector which is highly innovative and dynamic. So thank you very much for your attention, and I'm looking forward to the questions.
Thank you, Mr. Gal, for your insights on organic farming. And indeed, there are ambitious goals being set in this farm to fork strategy. So I'm sure there will be many questions about this. So Alejandra, I leave you the floor to moderate the questions.
Yeah, thank you. So here we have a question here. What concerns do you have with lower yields, let's say organic versus standard, in terms of carbon emission per ton plus food security, increasing global population?
So, I mean, first, there is research ongoing to close the so-called yield gap between organic and conventional, which is estimated on average around 20% at the moment. But I don't think this is a key question. I mean, if you look at, the key factors that drive greenhouse gas emission in the field of agriculture, they are linked to animal products and to the production of animal products to a large extent. So I think the key variable, whether we'll be able to reduce this emission from the agriculture sector, is not whether you farm organic or conventional, it's the level of animal production in a given region. So that's why you cannot envisage how we reduce emissions from agriculture separately from changes in diet, which are to a certain extent already happening at the moment as well. Plus, it depends how you calculate. I mean, like I always say, if you put 1,000 cows in a factory farm, on paper, you will get a reduction of greenhouse gas emission because you simply make a division between the greenhouse gas emission per liter of milk, for example. But it doesn't take into account all the emissions. For example, it doesn't take into account the emissions linked to the import of feed and protein from outside of Europe. It doesn't take into account other impact, like the impact on biodiversity, for example. So when we talk about how to reduce greenhouse gas emission from agriculture, we believe it's important to look at farming systems which allow to reduce all the environmental impact of agriculture, not only from a greenhouse gas emission point of view, but which provides benefits and synergies for biodiversity, water quality, etc. And last but not least, agroecological approach also sequester more carbon in soils too. So we are doing further research on that. Organic farming is far from perfect on every aspect. It's not the point here, but we do believe that it has a role to play in reducing emissions from agriculture in combination with changes in diet as well.
Thank you. Another question, so one of the targets of the Farm to Fork strategy is precisely to reach 25% of agricultural land under organic farming by 2030. How do you see possible to reach this 25% if not all people consume organic products?
Well, this is an ambitious target, but as I explained, I mean, first of all, you already have a very strong dynamic for the demand of organic products in many European countries in the last years, and we believe it will remain in the coming years. And on the other hand, we need policy support, and we believe that with a cap, which is, as you know, 40% of the EU budget, provided it's reformed in a way that it contributes to this farm to fork objectives and that it moves away from, untargeted direct payments to rewarding farmers for their protection of natural resources and ecosystem services. We believe that we have the tools in Europe to further increase both the production of organic farming, but also the demand, because indeed increasing the demand is part of a challenge, especially in countries of Eastern Europe. So that's why we see an important role for green public procurements, and ideally there should be national targets in all countries for having a share of organic products in public canteens, for example. And promotion policies can help as well. But you're right. I mean, I don't think the figures in itself. What is important is that we have policy tools in place at the national level to further increase the dynamic around organic farming. And we'll see whether we reach 20, 22 or 25%, but we need to put in place the actions to trigger a change now, because we believe it's very urgent to transform our food production system to make them more sustainable.
Thank you. The last questions is, are enzymes produced genetically also banned in organic products? Is this something?
I'm not sure I fully understand the question, but in terms of enzymes, as much as possible, it's complicated because enzymes are not regulated by the EU legislation on GMOs. So organic producers, they have to rely on vendor declaration that enzymes have been produced without genetic engineering as well. And yeah, so in theory, this enzyme should be produced without genetic engineering. But then, like in many other aspects, it's a problem. Sometimes you face a problem of availability. So it's possible that you can have derogation in some cases for this or for using other kind of inputs when they are not always available in organic quality.
This is all from my side. There are no more questions. Thank you. Thank you.
Okay, thank you so much, Alejandra. And this is indeed the end of today's session. And I would like to take the time to thank all speakers for their insights in the impact of the farm to fork strategy on the European fruit juices sector. I have to thank also our moderator, Dr. Alejandra Solis, for the fantastic job that she has been doing. And I would like to thank all participants to have been staying with us for this webinar. Tomorrow, we have the second day of our webinar, starting at the same time at 2 o'clock. So I can only wish you the best for this day and seeing you tomorrow.